Hello, my name is Joy Bongiorno, and today we're going to walk through making networks from the data that was generated within the past two lessons. So the first thing that we need to do is we need to install Cytoscape. If you haven't already, you simply download Cytoscape from the internet. I think there's a Windows version as well as a Mac version, so that's easily done here. Another thing that would be beneficial for you to download as well is if you go to the Cytoscape App Store, there's many different apps that you can browse through, including different ways to import data as you see fit. But what I like is these Y-Files layouts. Specifically, there are a couple that I tend to use within Cytoscape and I go to in this tutorial as well. So just by clicking the install button, you'll have that on your computer as well. Okay, so we also need to gather the data that we're working with. If you don't already have the Git repository cloned on your computer, I suggest that you do that. In order to git clone the repository, we open up a terminal and type in git clone, and then of course we need the link. So here we are on our Network Science Introduction GitHub repo. We click this green button, we have a link that we can simply copy and paste into our terminal, hit return, and it'll install this folder called Network Science Introduction. And it's in that folder that we have the analysis that we're going to, the analysis files that we're going to be working with today. So let's go ahead and launch Cytoscape. Okay, and once we have Cytoscape launched, we're going to import the data for analysis. So in the uppermost portion, we have this option to import a network from a file. We'll click on that. And it pulls up a directory for me to navigate to where we want to pull our data from. So in this analysis folder that you now have on your computer, there are a number of different CSV files that Jake and Jacob created out of their first two lessons. What we're going to import is this last one. It's called Terra Ocean Sphere Spar P1000 Glasso Analysis.csv. Okay, so it automatically imported every single column that we have in the CSV. The smart thing to do is to first select none, so everything becomes deselected. And then we have the options to assign meanings to each of the columns that we want to import. So variable A, we click on this little triangle here. Variable A is going to be our source node. Variable B is going to be our target node. So each of these represents a phylum of bacteria. And today we're just going to look at the Spearman network. There are different networks that are compiled in this one CSV. So I encourage you to play around and just take what you learned today and apply it to the other data sets. But let's characterize this row sphere as an edge attribute, meaning that's how we're going to define the connections between variable A and variable B. We also have an additional edge attribute in the p-value for that edge. Again, we click the purple. And then we have the false discovery rate for that Spearman row value here. And that's all we're going to select at this point. So we click OK. It's loading it in. And woo, we get a little clustered network that looks a little funky. So the first thing that you notice is that we have these self loops. We want to get rid of those, so all we do is edit, remove self loops. We select what we just loaded in, and it lets us know that 27 duplicated edges and self loops were removed. So just navigating around, we see that there are numbers over here in the left navigation pane. The first number is the number of nodes that are included in our network. So we have 27 different nodes, each node representing a different phylum. And then connecting those different nodes, we have 351 edges. Now I want to rename this network because I don't like how long it is. So we can right click, rename, and we can just call it Spearman. Awesome. So this network is pretty hard to look at. Everything is all stacked on each other. We can change the layout with different layout options, as I was speaking about earlier. So up here in the main menu, we have a layout button, and it gives you a whole slew of different network layout options. I just default to the organic, and you can read about the description of what the algorithm is for the organic layout on their webpage that I include in this tutorial that I'll upload later. So here is a view of our network now in a different layout. We can still sort of see that there's crowding of the nodes. It's kind of hard to see some of the labels. So we can mess around with the layout in an additional way by doing node layout options and then simply stretching the scale. Woo! Now it seems like we're really, really zoomed in, and all we did was blow up the network. As you can see here in the purple viewer, that's a portion of the network that we're taking a look at now. But there are lots of things outside of our field of view. To make everything fit back within this window, we just simply click this button here. It means fit content. And there we go. Everything's back in one condensed viewer screen. So now let's make some decisions on what edges and nodes we want to examine further. And we can do this by doing a selection. So we click select here, and we want to add a new condition to impose on our network. This will be a column filter. Remember, we imported several different columns. One of them was the P value. So I'm going to select P sphere here, and it automatically selects everything, every p-value that we have represented in our data set. And so the range is quite large. We have everything from very close to 0 to practically 1. And so if we're trying to make determinations about statistically robust connections in our network, it's wise to take a look at the things that are of an acceptable p-value. And so for our case, let's just define that as less than 0.05. So between 0 and 0.05. That's our new range. And so you can see not each and every edge is now colored red. We have some that are gray, which means they did not make that cutoff. We can hit apply, which I think it automatically applied that. And so that's great. Things are selected now, but how do we make a new network? And that's pretty easy. But the first thing that we have to do is select all of the nodes that are connected to those edges. So up at this top menu, we say select nodes, nodes connected by selected edges. There we go. It just so happens to be every single node is connected to a edge with that cutoff imposed. So now that we have our edges and our nodes selected, let's go ahead and generate a completely new network with File, New Network, Selected Nodes, and Selected Edges. Boom. So let's take a look at how many things were removed. Okay, so here's our subnetwork that we just generated. Let's go ahead and rename that real fast. Let's call it Spearman P0.05. The number of nodes remains the same. That's no surprise because all of them were selected when we asked it to select the adjacent nodes. But we lost some edges here. We lost about 40 of our edges, which is pretty interesting. Okay. We can also manipulate styles and render our edges and our nodes different colors based on different attributes that we read into our network to begin with. So the first thing that we want to do is make use of the Spearman correlation coefficient that's underlying each of these edges. So under the control panel, we have the option of style. We can select edge. And now what I want to do is I want to change the stroke color based upon some conditions of row. So column. Let's select row sphere. Mapping type is going to be continuous. And I already have a palette here because this is how I work with my own data. We can double click that palette and it'll open up this mapping editor. Just for fun, let's reset the min and max for our row. We see that the lowest row that we have in our data set is negative 0.86, and the highest is positive 0.86. I don't know if that's an artifact or not, but we just hit OK. And much like the PowerPoint way to change gradients, this is very similar in that you can add additional color markers if you wanted to. I want to get rid of that because that's not what I'm wanting to do. So here I have a color marker on the very far right, which represents our positive connections. I can change that color to be whatever color I want by double clicking this. I made it red for positive. Then here at the far left, we can double click that. I made it blue for negative. And here in the middle where the row is 0, we have this indicated with a white color. We just hit OK. And we see that our positive connections, so row greater than 0, are now colored red, these red edges, and our negative connections are now blue. We can also mess with the width by scrolling down. The default right now is 2, so the width of all of these lines are represented by the same size. But let's again assign one of our columns to render that width a different width. So we want to select row sphere again. We would do continuous mapping. And now it turns into a bunch of spaghetti. That's where we can open this editor again by double clicking. Set min and max. Oop. Okay. And so for this, it'll look very much like the palette where we will have 3 breaks, 1 at 0, 1 at the max end, and 1 at the min end. And so let's go ahead and push this middle width as far down, as close to 0 as we can still see it. So maybe not 0.2, go up to about 1. The far right and the far left need to be the same if we're going to visualize things in an equitable way. So we can go ahead and make that about 13 to 15. I can't see what that is actually. That's like 10. Okay. Let's say those are roughly equal. Oop. And we hit OK. Cool. So now we have our strong positive rows indicated by a deep red that is thick here, probably. And then our strong negative row values are represented by a thick blue line. And if you're interested in zooming in and out, you can just take your fingers and scroll back and forth. I know you can't see what I'm doing, but you can also use these as well. Okay. So now that we've manipulated the color and the width of our edges, let's start playing with node attributes. So back over here with our control panel, let's move over to node and fill color. But what I'm interested in is breaking up these nodes into which phyla are bacteria and which phyla are archaea. I don't have that information in my table right now, but let's say I already knew that information, or let's say I'm interested in which bacteria are sulfate reducers, which ones are methane oxidizers, and I have that information in a separate place. That separate place for me is a file that is also in the analysis folder in the repo called kingdom_phylum. And so all this is a list of all of the phyla that are represented in our network and their corresponding kingdom or domain, whether it is bacteria or archaea. Let's go back to Cytoscape, go back to network, make sure that this is selected here because that is the network we're continuing to work with. And so let's go back up here, and instead of importing network from file system, we're going to import table from file. You click that button. Should open up the last thing that we were in, the last directory. Let's select Kingdom Phylum, open. And this looks very much like how we were importing our network, except now we're mapping attributes onto our existing node table. So here, phylum, that is going to be our key because those are the names that already exist in our table that's in Cytoscape. And so now when I hit OK, the kingdom is going to automatically map to the phylum that it finds in the table. Here we go. So we can check out what we just did in this table below. We have shared name and name. They're the same. I don't know why Cytoscape makes two columns for the same thing. But now we see that we automatically have a third column that includes the kingdom or domain that phylum is found in. And you'll see that this is blank because it's unassigned. So we can use that information then to render our nodes different colors. We go back to Style, Node, Fill Color. And we're not going to use the name. We're going to use the kingdom information that we just read in. This gives you the option of discrete mapping. So we want to choose the colors ourselves. So for Archaea, we click here, Edit Color. We can make the Archaea, I don't know, teal. And automatically everything that is an Archaean is teal. Bacteria, let's change that to, I don't know, orange. Ooh, I don't like that. Let's change that to pink. All right, so now all of the nodes in our plot that are bacteria are pink. Everything else should be an Archaean or unassigned. You'll notice that unassigned is the default blue color here. You can get really wild and crazy with these node attributes. Let's say you were doing paired 16S DNA and RNA transcription, and there were some nodes that had RNA transcripts and some that didn't. You can get creative and say, render the border paint a different color for something that was transcriptionally active versus something that wasn't. People get really creative with their networks. So other things that are good to know about Cytoscape is the ability to analyze your network using some statistics. So up here at the top, we have tools. We go to Network Analyzer, Network Analysis, and then Analyze Network. We can click on this and it asks us if we have a directed or an undirected network. All of these edges are undirected, so we click OK. And you'll see now our table down here is populated with a whole bunch of more information. Things like average shortest path, clustering coefficient, closeness centrality. A lot of that is stuff that we'll get into later on. But just for today, let's play with one of those attributes or one of those statistics, which is the degree. And degree is simply how many edges is connecting to a single node. So let's do some more mapping with our nodes and change the size of the node based on the degree that it was found to have. So scrolling down here for our control panel, size seems to be grayed out, and that happens to me sometimes. If you hover over here, it says you have to click something called lock node width and height. That's right here. Click that. We're good. The default value is 35. We want to change that. We want to select the column, the new column of degree, which is here. Mapping type is going to be continuous. And then we can change the size of the dot just by double clicking here. So the set min and max, our minimum value is a degree of 18. Our maximum value is a degree of 26. So the 18, let's see, let's make that not too small. And let's make this, whoa. Here we go. We're just playing around. Okay, so 18, a degree of 18 is going to have a point size of 22, and our max of 26 is going to have a point size of 216, just for fun. And that's what our new rendering looks like. You see that bigger nodes have more edges coming from them, and smaller nodes have fewer edges coming from them. Searching. Let's say your network was not as tractable and visually appealing as this one, and you had hundreds of nodes and hundreds of thousands of edges, and you were interested in just one type of phylum. So let's try to find cyanobacteria. We can click up here and do a search for cyanobacteria and click enter. This will select all of the edges that come out of cyanobacteria, as well as the node itself. If we were interested in the partners or the other nodes to which cyanobacteria is connected to, we can right-click cyanobacteria, select first neighbors, and now everything that's connected to cyanobacteria is also selected. We can take this information and create yet another network. So File, New Network, from selected nodes, selected edges. And there is our Cyanobacteria Center of the Universe network. Let's say that still your network was pretty large and you know that there was one SAR node somewhere. You don't remember the number that came after SAR. So we can use wildcard when we're searching as well. So for here, I see a SBR, which will work. So we can do SBR wildcard, and boom, it gave us the node that satisfied our search here. Finally, we want to, of course, output our lovely network. We can take a screenshot. Sometimes I do that, and that's fine. But for publications and for PowerPoint, it's best to simply export it. So down here, we have this little button, Export to File. We can export as network or export as image. I always export as image. It'll ask you the file type. It'll ask you where you want to save your network image and what you want to call it. So it'll automatically give you the base name of the network, but we didn't rename it yet. We'll call it Spearman P0.05 Cyano. I like to zoom in just for fun, 250, and then okay. And now you have the network saved as an image on your computer. We can save the entire network session, which will remember your style enhancements and your selection parameters just by clicking save. And I think that's all I wanted to show you. I encourage you to maybe build networks out of the other data sets that we have included in the same CSV that I uploaded during this session, and see if you find any topological differences, any differences in degree for specific nodes. Yeah, so thank you.